Hi everyone! Have you ever heard the term efficiency and wondered what that meant? In this video, we will explain to you what efficiency means, why it's important, and an experiment you can do to understand efficiency with just your household items. First, some introductions. We are the University of Alberta EcoCar team. My name is Willow, the project manager of EcoCar, and with me we have Anita from the mechanical team and Jade from the fuel cell team. So, what does EcoCar do? We are a team of undergraduate students at the U of A who work together to design and build hydrogen fuel cell powered cars. These cars might look like a normal vehicle you would see on the road or on a racetrack, but there's something special about them. They don't have an engine like most cars do. Instead, they get power to drive from something called a fuel cell, which I will explain a little more in depth later in this video. So the next big question is, why do we do it? You may have heard a lot about something called sustainability from school or on the news. Sustainability is the idea that the technology we use now shouldn't be harming our planet for the future. Unfortunately, cars and trucks that we use nowadays contribute to negative effects on the environment, such as air pollution and global warming. Transportation is the largest source of carbon dioxide emissions in North America. Carbon dioxide, or CO2, is a small molecule that is emitted when fuels like gasoline are burned and acts as what's called a greenhouse gas to contribute to global warming. Fuel cell cars like ours emit no air pollution and no carbon dioxide, so if everyone drove a fuel cell car, we would emit less greenhouse gas. In EcoCar, we believe that fuel cell vehicles will play an important role in building a more sustainable future, which is why our motto is, building the future, one fuel cell vehicle at a time. Our team is made of students studying all different kinds of engineering, as well as business. We are organized into three main teams. The mechanical team designs and builds the physical systems of the car, like the shell and the chassis. The electrical system team makes sure that electricity gets from the fuel cell to the motor in order to drive the car, and also builds systems such as headlights. The fuel cell team makes sure the fuel cell runs in order to produce the energy our car needs. So, what exactly is a fuel cell? A fuel cell is a lot like a battery, but you never have to recharge it. It takes hydrogen on one side, called the anode, and oxygen from the air on the other side, called the cathode. The cathode and the anode are separated by a barrier called a membrane. There, an electrochemical reaction takes place, which takes two hydrogen and one oxygen molecule and turns it into H2O, which is water. This reaction generates electricity, which then goes on to power the car. The only byproduct is a tiny bit of water, which is safe to release into the environment. As well as emitting no carbon dioxide, fuel cells are also great because they are very efficient. On that note, what is efficiency? Simply put, efficiency is a ratio of how much energy you need to put into a system compared to the useful energy you get out of the system. In a heater, for example, you put in electrical energy and you get heat energy out. So the efficiency is the amount of thermal energy from the heater divided by the amount of electrical energy you put into the heater. Now let's take a look at an activity you can do at home to see what efficiency is for yourself.
Hello, today we're going to be testing 3 methods to propel a car to see which one is the most efficient. The methods we're going to be testing are a balloon, an elastic, and a ramp. You will need balloons, elastics, books, and one car of your choice. We're using Hot Wheels, but you can use a car made of Lego or anything else. Measuring tape and some tape. Dogs to help with the experiment are optional. To start, write down your prediction in the worksheet of which method you think will be the most efficient. The first method we're going to be testing is the balloon. Mark the starting point on the ground with a sticky note or your ruler or some paper. Blow up your balloon. You might need someone to help you with this part. Pinch the end of the balloon to stop the air getting out and attach it to the car with a little bit of tape. Then line the car up at the starting point and let it go. Once the car stops, measure the distance from the starting point to where it stops and write the distance in the worksheet. Next, we're going to propel the car with an elastic to slingshot it. Line up the car at the starting line and loop the elastic around your fingers like this. And pull the elastic back with your other hand. Line up the elastic with the back of the car so when you let it go, it will hit the car and release your finger. Same as before, measure the distance from the starting point to the car and write it in the worksheet. The last method will be to propel the car with a ramp, just like a slide for your car. For my ramp, I'm using 2 thick books stacked up and another book on top at an angle to the ground, but you're welcome to be creative and use whatever materials or design you'd like. Put the car at the top of the ramp and let it go. And then measure the distance the car traveled and write it in the worksheet. My car went so far that I had to get a different measuring tape because mine wasn't long enough. Which method made your car go the farthest? For me it was the ramp, but it might have been different for you. If your balloon was smaller or bigger, you had a different elastic, or had a lower or higher ramp. As you learned earlier from Willow, efficiency is a ratio of how much energy you need to put into a system compared to the useful energy you get out. According to the law of conservation of energy, the total amount of energy is conserved. Energy never disappears, it just changes to another form, and some energy transfers are more efficient than others. In this case, the useful energy that moves the car forward is called kinetic energy. The balloon, elastic, and ramp all have potential energy. When we are trying to figure out which method was the most efficient, we have to look at how far the car went and how much energy it used. Methods can be less efficient if energy is lost to something that doesn't propel the car forward, like the balloon spinning the car around in circles, or even the elastic making a sound when it snaps. That's lost energy. The balloon wasn't very efficient because it took a lot of energy to blow it up, and it didn't go very far. The elastic was less work and the car went farther, but the ramp was the least amount of work and the car went the farthest, so the ramp is the most efficient. Next, Anita will be talking about how we design our car to be really efficient.
When you're trying to build the most efficient vehicle possible, there are more things to consider than just your energy source. You can design both the internal and external components of your car to be as efficient as possible. When you're designing for efficiency, the simplest parts to consider are the weight and aerodynamics of your vehicle. The more your car weighs, the more energy you need to propel it forward. Less weight means less energy needed to move the car. Because of this, you need to consider the weight of your car when you're designing components such as the shell, chassis, and suspension. Of course, if you want to, you can design a car to be an indestructible brick made of pure steel, but that would weigh thousands of pounds and be extremely inefficient. Instead, you can make components of your car out of lighter materials, such as making the shell of your car out of carbon fiber, or choosing less dense metals like aluminum. The second thing to consider when designing a vehicle is aerodynamics. For a car, there are two main forces you need to consider. Drag is the force acting in the opposite direction to the motion of the car, while thrust is the force propelling the vehicle forward. For us, this force is generated by the hydrogen fuel cell. On the mechanical team, the main force we concern ourselves with is drag, and a lot of what we do is coming up with ideas to limit it. From the drag equation, we can see that it is directly proportional to the speed, the drag coefficient, and the frontal area. To start off with speed, you can see that drag will exponentially increase the faster you go. Because of this exponential increase, speed is the main factor in determining drag. At low speeds, drag will not have much of an effect on your car. In the early 20th century, cars were designed like bricks, as seen in the photo on this slide. Their top speeds were around 30 miles per hour. They did not need to be designed like a sports car since drag would not have much of an effect on them. Our car also has a top speed of around 30 to 50 kilometers an hour, so drag even for us is not that much of an issue. However, when you're trying to build the most efficient vehicle possible, everything matters. The drag coefficient is dependent on a variety of factors, the main ones being the shape of your car, the smoothness of the surface, and your speed. For example, a cube or a truck will have a drag coefficient of 1, while a teardrop shape will have a drag coefficient of around 0.04. For the frontal area part of the drag equation, it basically means that the smaller the surface area of the car means that there's less material for the air to push against. This results in less drag. For us, we mainly look at limiting the drag coefficient and frontal area of our car. We personally have achieved a lower drag force by designing an aerodynamic outer shell that is also smooth and sleek.
Thanks, Anita. So to summarize this video, efficiency is the ratio of energy that is input to a system to the energy output of the system. Fuel cells are very efficient and emit no greenhouse gases, which is what makes them great for our team. On EcoCar, we design efficiently by making our car light and aerodynamic. Thanks everyone for watching, and we hope you learned something about efficiency.
Thank you so much for watching Future Energy Systems video. Make sure to subscribe so you don't miss any of our exciting content. Check out the links below to our website and learning page where you can find activities, learning extension, and more. You can also sign up on the website for notifications for future videos and interactive opportunities. There's so much to learn as we explore our energy future.